Hi, my name is Jacob. I'm the captain of the Irving Johnson here at the Los Angeles Maritime Institute, and today we're going to talk about mechanical advantage and pulleys. Mechanical advantage is taking moving parts to make something easier, and we can get mechanical advantage through simple machines like pulleys. So this is a pulley. There's a pin that goes through the actual pulley itself, and when you spin it, you can see it actually will start moving, and you can put a line through it like so, and then when you pull the line, the pulley will actually move like this. Alright, but it's hard to use this practically and mount it, so what we do on boats is we turn this into a block. Alright, so there's a piece of wood and the pulley is on the inside, and so then you put the line through the block like so, and this keeps it nice and controlled. Before we get started, we're going to need to talk about a few basic principles of pulleys and physics. Newton's second law states that force equals mass times acceleration. So we can figure out the force needed to lift Sam based on his mass and the acceleration from the force of the Earth. Sam's mass is 81.6 kilograms, and the force of the Earth on him is 9.8 meters per second squared. Therefore, we can round up and know that the force in newtons to lift Sam is 800 newtons. We also know that work equals force times distance. So if we want to lift Sam a meter, then we need to do 800 newton meters of work. We can break this down for pulleys into another equation, which is our input force and our input distance equals our output force and our output distance, where the output force will be Sam's and the output distance will be how high we raise him. The input force is how much force we have to pull on the line, and the input distance is how much line we actually have to pull to raise him. Now we're going to try to put pulleys into action. So we're going to try to lift our deckhand Sam here with a single line going up to a single pulley all the way up the mast. Are you ready, Sam?
Aye, sir.
That single pulley is not going to make it easier to lift Sam. All it does is it changes the direction that I'm pulling. So you see, I can pull down and Sam will go up. So that is the point of that pulley up there. It is not making the work any easier for me. So that didn't work. And it did not work because Sam's weight and his force are greater than my weight and force, right? So if I were to just try to pull Sam up with all of the force I can muster, I can't do it. And this is where mechanical advantage and pulleys come in handy. So now we have our pulley, and it has two pulleys on it. There's one up here and one down here. So one is changing the direction, and these two lines now are both going to share the load of Sam. What this should mean is I can lift Sam twice as easy as I would have been able to do before. What I'm going to have to do though is pull twice as much line, because to get the block from here to here, I have to pull all of this line through. So it's double the amount of line. We're going to have Sam measure here at our output distance, which is
Roughly 4 feet and 7 inches.
4 feet 7 inches. So that's 1.4 meters. Now, if I put my hand here to mark the starting point, we're going to measure the input distance, which, if our theory holds, will be double our output distance. So what do you get for that, Sam?
Yep, 4 feet 7 inches.
Times 2, and that's going to give us in meters, about 2.8 meters. The equation we can use for this is the input force times the input distance equals the output force times the output distance. And you'll see, I will be able to lift Sam. We know that the output force, or the force to lift Sam, is 800 newtons, and the output distance is 1.4 meters, which is how far Sam actually rises. The input distance is 2.8 meters, which is how much I have to pull. Now with the known values we've given you, try to solve for the input force, which is the amount of force I had to put in to lift Sam. So we're back where we started, but this time, instead of just having one pulley, we have 5 pulleys. So now I have 5 times the mechanical advantage that I had to start, which means it'll be 5 times as easy for me to lift Sam, but I'm gonna have to pull 5 times as much line. But I think I can lift Sam with one hand now instead of having to put my full body weight into it. So let's try.